Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. In this lesson, I will continue the paper for 0620 March 2022 and the paper is paper 42. I'm already done with the question number 1 till 4. In this paper, in this video, I'm going to solve question number 5 and 6. Let's begin the video. This question is about alkanes and alkenes. Short chain alkanes and alkenes can be formed from long chain alkanes in a chemical reaction. Name the type of chemical reaction which forms short chain alkanes and alkenes from long chain alkanes. There's only one reaction in your syllabus, and that is cracking. So you write cracking here. Number 2, decane has 10 carbon atoms. It forms ethane and ethene as the only products in this type of chemical reaction. Write the chemical equation for this reaction. You know the formula of decane. Recall the general formula of alkane, which is CnH2n plus 2. If you will put the value of 10, what you will get? You will get C10 H 2 multiplied by 10, 20, 20 plus 2, 22. So we'll write C10 H22. We are cracking C10 H22. And the products they have mentioned ethane and ethene. Simply write the formula of ethane and ethene first. The formula of ethane is C2H6. Ethene is C2H4. Now we have to balance this equation. If you look at the formula of the reactants decane C10, we have 10 carbon atoms, and on the product side we are having 4 carbon atoms. So it means we have to add 3 more carbon atoms. So what if I'll write 4C2H6? If I'll write 4C2H6 plus C2H4, count the number of carbon atoms. 4 2 is 8, 8 plus 2, 10. What about hydrogen? 6, 4, 24. So it's not possible. This is wrong. What if I will write 4 before C2H4? Let's do this. C2H6 plus 4 C2H4. Count the hydrogen atoms, carbon atoms first. 4 2 is 8, 8 plus 2, 10. What about hydrogen? 4 4, 16, 16 plus 6, 22. So this will be the right answer. So you write 4 here. Part B. Ethane reacts with chlorine at room temperature to form chloroethane, C2H5Cl, and one other product. Name the other product formed. It's very easy. It's a substitution reaction of ethane. The other product is hydrogen chloride. As you are reacting with chlorine, so you will get hydrogen chloride. If you are reacting with bromine, you will get hydrogen bromide. State the condition needed for this reaction to take place. Ultraviolet light. It's a free radical reaction, so it takes place in the presence of ultraviolet light. In fact, it's an example of photochemical reaction. Photochemical reactions are those reactions which are catalyzed by light. Ethene reacts with chlorine at room temperature to form dichloroethane, C2H4Cl2. This is the reaction. C2H4 plus Cl2 gives C2H4Cl2. State why this is an addition reaction. Answer is very simple. Only one product is formed. Only one product is formed. Next part, this is a reaction. This question, the chemical equation for this reaction can be represented as shown. This is displayed formula of ethene. This is chlorine, and the product is dichloroethane. The energy change for the reaction. The energy change is given minus 180 kilojoule per mole. Use the bond energies in the table to calculate the bond energy of a CCl bond in kilojoule per mole. Use the following steps. Step number 1, calculate the energy needed to break bonds. So we are having ethene and Cl2. How many bonds of CH are broken? 1, 2, 3, 4. So you will multiply 4 by CH bond energy is given 410 plus C double bond C is given 610 plus CL bond is also given 240. What we will get? We will get 2490. Use your answer in step 1 and the energy change for the reaction to determine the energy release when bonds are formed. We know the formula. The formula is overall energy change is equal to energy required to break bond. We have already calculated plus energy released, bonds made, bonds are. We need to calculate this. So overall energy change, what is it? It's given here. Sign is also minus 180. We'll write minus 80 here. Minus 180 gives energy required to break bond is 2490 plus x. So x is equal to minus 180 minus 2490. Sorry, there's a mistake. The sign is minus here. So definitely this one is also minus. So the answer is minus x is equal to minus 2670. So the final answer 2670. Use your answer in step 2 and bond energy values to determine the energy of the CCl bond. If you look at the data table, CC bond is given, CC and CH bond is given. So what we will do? We will add up these bonds. We have one CC bond and 1, 2, 3, 4, 4 CH bond and 2 CCl bond. So we have 2x for CCl, as there are 2 bonds, plus the CH. What about CH? 4 into CH bond 410. 4 into 410. 4 into 410 plus CC is also there, only one CC. So it's 350 plus 350. And it should be subtracted from 2670. Sorry, it should be equal to 2670. So we will get what we will get. We will get 2x is equal to 2670 minus 1990, and 680 will be the answer. Then we'll divide 680 by 2 in order to get the value of X. So it will be 340 kilojoule per mole. The names of 4 esters are listed: methyl propanoid, ethyl propanoid, propyl propanoid, butyl propanoid. Esters are a family of organic compounds with similar chemical properties. They can be represented by the formula CnH2nO2. State the name given to a family of organic compounds with similar chemical properties. The general term use: homologous series. Explain why members of a family of organic compounds have similar chemical properties. Only one reason: they all have same functional group. State the name given to a formula such as CnH2nO2. It's journal formula for the family esters. Determine the value of N in butyl propanoate. Butyl means 4 carbon, propane means 3 carbon. So N should be 7. All 4 of the esters in the list are liquids at room temperature. Name the technique used to separate ethyl propanoate from a mixture of the 4 esters. Fractional distillation. Fractional distillation involves the separation of miscible liquids. They are miscible liquids. All 4 esters can be made by reacting different alcohols with the same substance. Name this substance and draw its structure. Show all of the atoms and all of the bonds. Name, structure. It's propanoic acid. Very easy, propanoic acid. The reason is that we are getting propanoate. Propanoate is coming from propanoic acid, and the alkyl group is coming from alcohol. So we have to draw the structure of propanoic acid. There are 3 atoms of carbon, 3, 1, 2, 3. The third one will definitely carries the functional group, that is COOH. I'm showing each bond. Name the alcohol used to make methyl propanoate. Methyl, alkyl is coming from the alcohol. So we have methanol. Other esters not in the list have the same molecular formula as propyl propanoate, but different structures. State the term used to describe substances with the same molecular formula but different structures. They are called structural isomers. Name 2 esters with the same molecular formula as propyl propanoate. You can have ethyl butanoate, you can have butyl ethanoate. Polyesters can be made from the 2 different molecules shown. Complete the diagram to show a section of the polyester made from these 2 molecules. Include all of the atoms and all of the bonds in the linkages. So if you look at the shaded, this one, it's carrying COOH. So what you will do, you will write COO here. On the other side, you also show COO. In fact, when you are drawing, this one is coming here, and in this one will get this chain bond O, chain bond O. So it's alcohol. Again, you are having same chain bond O, C double bond O, C O O O, so on. Name the type of polymerization that takes place when this polymer forms. So where is condensation polymerization? Because it involves the release of a simple molecule like water, sometimes HCl. Name a polyester, it's terylene. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.